Hello. Next we will see the unit impulse signal denoted as delta t, and it is defined as delta t equal to 0 for t not equal to 0 and its integration is equal to 1, means the area under the unit impulse signal is 1 and it is 0 everywhere where t not equal to 0. So if we plot this signal, unit impulse signal will get this signal. So this is t axis, is t equal to 0 and so this signal is 0 everywhere except t equal to 0, and at t equal to 0 it is undefined actually. So it is not exactly defined at t equal to 0. So this is the unit impulse signal delta t. Now it is not possible to practically generate this unit impulse signal. So what we can do, we can approximate this signal by other signals. Consider this rectangular signal which is of width epsilon and of height 1 over epsilon. So this is some signal x of t, which is this rectangular signal, rectangular pulse. So if this width is very small, then this height will be very large. So when this epsilon tends to 0, this signal, this pulse will approximately be equal to the unit impulse signal delta t. Now not only this signal approximates the unit impulse, but we can have other approximations also. Further, we can see that the unit impulse signal can be approximated by using these pulses or using these signals also. For example, this is a decaying exponential and this is a triangular pulse and this is a Gaussian pulse. Okay, now if alpha tends to infinity, then this signal will behave as a impulse signal, okay, a unit impulse, and we can say that the area of this signal, area under this signal will be equal to 1. Okay, we can check this, and for this triangular pulse this area is 1, and so if the epsilon tends to 0, this will be approximately unit impulse signal, and similarly in this case, if the epsilon tends to 0, then this Gaussian pulse will be approximated as a unit impulse signal. Okay, now further we can see that the signal k into delta t will be equal to 0 for t not equal to 0, and its area k into delta t dt will be equal to k. So in this case the k is the strength of the impulse. So earlier we have seen that if this area is equal to 1, then we call it a unit impulse. Okay, unity means the strength of this impulse is 1, or the area under the impulse is 1, and in this case this k is the area under this impulse k into delta t, or the strength of the impulse. Further, let us see few properties of the impulse signal. Okay, so first one is the unit impulse signal is symmetric. So it means that delta minus t will be equal to delta t, and delta of a into t will be equal to 1 over mod a delta t. The third property is that the integration from minus infinity to t delta t dt equal to 0 if t is less than 0 and equal to 1 if t is greater than equal to 0. And we can see that this is nothing but the unit step signal. Okay, this is the definition of the unit step signal. It means we can relate this as u of t equal to integration from minus infinity to t delta t dt. The last one is known as the sampling or the shifting property of impulse. It means the x of t into delta t is equal to x of 0 into delta t. We are considering that the signal x of t is continuous at t equal to 0, and x of t into delta, say t minus t naught, will be equal to x of t naught delta t minus t naught, considering that this x of t is continuous at t equal to t naught. And if we integrate this, we will get x of t to delta t dt is equal to x of t. Similarly, okay, so this is known as the shifting or sampling property of unit impulse signal. What does it mean is that if any signal x of t is continuous at say t equal to 0, and if you multiply this with unit impulse, so this is unit impulse signal, and if you multiply these two signals, what we will get is the value of the signal at t equal to 0. So this value is x of 0. So we will get an impulse of strength x of 0. Okay. So multiplication of this signal with impulse will give us another impulse of strength x of 0. And if x of t is continuous signal and we multiply this with a shifted impulse, so this is an impulse delta t minus t naught, which is shifted at t naught. And now, given that this signal is continuous at t equal to t naught, if we multiply these two signals, we'll get impulse of height, which is equal to the value of this signal at t naught. This is t equal to t naught. This amplitude will be x of t naught. Okay, so we'll get an impulse of this strength x of t naught. So this is the shifting property of unit impulse. So we'll stop here. See you next time. Thank you.